Well, if you can hear me above the air conditioning, oh no, I'll just turn the background music down. You'll probably be aware we've got a AKD 2001 2-metre ham radio set and the 4-metre one, the 4001. Sure, we've got the 7001 7cm one somewhere, but I can't find it. And then this has appeared, and it's one of the viewers said he knew somebody who was selling this, and so it's come in its box, and that's always nice. Oh, and a standard Altai mic as well to go with it. So we're going to do a service on this. I was going to do this Saturday, it's Friday today, but we are going to do the on the air test tomorrow, and can really only arrange that on Saturday. Don't need a mic clip with it. So it's very nice to have the instruction book, because I've got a sneaking suspicion there'll be a circuit diagram. What I like about these is they're a bit more reminiscent of business radios, which is what my background is. I'm not into displays and functions, and I'm an on-off volume and squelch person. My Heathkit, does this come out of here? My Heathkit HF gear. Is this sealed? It doesn't even have a clarifier control, you know, and I like that. I've got a guarantee anyway. Glad about that. I've got to send it into Unit 5 Parsons Green Estate, Stevenage. Yes, there's a circuit diagram. So that's fantastic. 1993 that's dated. So it's 25 watt radio, 50 to 51.99. Handily it tells you the pin out for the mic. And it may even tell us what channel does what. It does tell us what channel does what. Excellent. So I've got a circuit diagram. It's basically done by a PIC chip. 5V and 8V regulators. MC3357 IF audio IF receiver subsystem. TBA 820 audio amplifier. And a much loved BF 981. Put the right glasses on. There we are, that's better. Yeah. Right, so we'll open it up. And when we've looked in the 2001 and the 4001, it's been a double-sided, plated through fiberglass printed circuit. And it is here. And a Matsushita relay. Right, well, we'll better connect this to our 18 amp power supply, with it being a 25 watt radio. That's what we have for the business radios. The lead's not that tonker, but I'm sure we'll do. Expect their idea of 25 watts is 18, but there we go. So put the power supply on, which is going to cause a hum. Put it on low power for now, and plug the mic in the right way. One of the good things is the forward facing speaker, and channel 35 is what? We're going to have to set our test gear onto this band. So channel 35 is 50.89. Well, it looks to me like 74's calling channel, 51.51. So I think we need to be setting it up on 51.51. So we'll set the signal generator, and I'll show you me faffing around doing it. (51). So next major one, next major one, I think that's the one. 51. .51. You've got coarse and fine on this signal generator. So there we are, 51.51. We just get that extra digit out. Yes, 51.51. So can we hear that signal generator, which is currently 0.3 microvolts? No. Oh, of course we won't. It's on the wrong channel, isn't it? Okay, we still can't hear it. Perhaps we have to plug the aerial in. I also like the fact they don't have a meter. What on earth do I need to tell people what it says on a meter? It's interesting. It says 51.51, and I'm getting 51.53 coming through. Like it's 20 kilocycles off, 200 kilocycles, something like that off channel. Let's see what it's transmitting on. 51.489 miles off frequency. No wonder they got rid of it. Absolutely miles away. So, look at your circuit diagram. We've got a reference oscillator for the CPU. which is supposed to have a variable trimmer, which I can't spot. Is that it? 6057. Yes, it is. So we have a reference oscillator just there. I'll see whether we can alter anything with that. The highest we can get that is 51.49. So do we have another one which is going to affect transmit? I'm going to change, I think we're going to change this to channel 46, which is 51 dead. So reset the signal generator. Okay, so we're at 51 megs on there. So we'll just check once again. So channel 46 is 51 exactly. Channel 46, press transmit. Miles out. So what can happen is reference crystals can drop with age, but this is out of spec. I'd hate to have to spend 30 odd quid getting a new reference crystal manufactured. I'm hoping it's something standard enough for the peg. So I think we'll get the little oscilloscope out, which has a built-in frequency counter, rather than use the instrument one on here. I'll tell you what, we'll try this one first. Four megs, so we're going that one. So what pin does it go in at? It goes in at pin 1 and 2. So I can just touch that on there and we should get a reading. I think we'll use the prod as a probe. .8. We're going backwards. About as high as we're going to get that. So it should be 4. So the crystal's dropped and it's dropped out of spec. So I'll go and get the... I will still go and get the little oscilloscope. So now going back with the oscilloscope, we've got 3.999. This might... strange. I wonder if my test set's out on 50 megs. So we've got 4 megs there exactly. We should have 51 exactly, which we haven't. Now what does this oscilloscope go up to? .9336. I think it's a 60 meg scope that. So that says 50.9336. This says 50.933. So they are in about in correct place with each other. So what's causing that? I hope it's not tuned with the VCO coil. Nope. Let's look further. Right, I've done a bit of research. This rig isn't as screwed up as we think. So it says here the calling channel's 51.51 and it's on channel 74. I looked at an old Radcom article from 1992 which reviewed this. I managed to search for that, and it says, and it boosts up on channel 75, which you'd assume to be calling channel. 75 is 51.51. So this one is one channel out to what the book says. Now this book was in a sealed packet, and is this book a newer EEPROM or whatever it is to what the original is? So I think this has got different software to what this book is saying. So if that's the case, we want this on 51.51. So 51.51304. So we should be able to trim that to be spot on frequency. But it was useful to verify that that crystal was working correctly. So we'll trim that now for 51.51. There we go, 51.51. That'll do me nicely. So we already tuned up the transmitter. I don't know whether we showed that on the video. And so we'll just go through, I think that's transmit. Hard to tell. So the parts aren't labelled, so it's a bit guessworkish. We'll need to do the trimmer for the transmitter. It's doing a good 25 watts. It's actually doing 28.5 watts. I don't think that's adjustable, it's just the way it is. I'll just detune this and see what happens. It might be receive, but it looks like transmit. It is. Tell you what, we'll detune that so that it's about 26 watts. Put it in low power, and what have we got? About 4 watts. So we'll go back. We'll go to the watt meter. So we're just about at 3.95, and then on the I've switched it off. That was silly because now it'll need putting back on channel 75. And there you have it, just over 25 watts. So I'm not sure where deviation is going to be. So we need to alter this. I think we're in the right range now. Might not be. Now why can't I find it? That's 25, 40, 60. That's the one we should be on. So we'll verify we're on 51.51, which we are. Back to deviation. Got it. Wallow. 1 2 1 2 1 2 1 2 1 2 wallow. 1 2 1 2 1 2 1 2. It's about 3 kilohertz. So it's probably right for the spacing that is actually on. So let's look at sensitivity. 0.3 microvolts is coming through. So we'll plug in the test equipment. Switch the bench light off so we can see the detector, put an S9 equivalent signal of 100 microvolts and turn the volume up, and when we'll set the detector, I'm looking for the yellow tool, but we can use one of these. When we find the right one. It's the one that's on the floor. So the detector or demodulation is going to be this one. I think we gained a little tiny bit there. So just go through cyanide like we would with any other set. He's spot on this, you know. Not sure whether this is transmitted. It is. So let's look at what we've got. We've got 0.31 on that scale. For 12 dB, let's change scales because we're between scales like we often end up. Yeah, so I've got 0.295 on one scale, 0.31 on the other scale. So we can safely say it's 0.3 microvolts for 12 decibel cyanide. So it's very sensitive. Good. So deviation is there. VCO, which we don't know how many instructions on adjusting, is there. We set the frequency there. Detector, receive, transmit driver, and the transmit ones are there. So that's not an awful lot to do. We did get the circuit diagram with the set. We did get a block diagram. And then we get an instruction book which has got different channels to what this radio's actually got. So that's going to be interesting. So I'm going to have to pick one or two spot channels just for us to be able to do an on-the-air test with. I'm going to have to knock it up a bit from the calling channel. But in the Radcom article, it says that it will be available with repeater shifts in as a special request or as a future date. Well, this manual shows it with the repeat shifts in, so this is clearly a bit later, and because of that the software is different. So I need to get hold of an old manual. Well, tomorrow evening we're going to do an on-the-air test, and Mr Chippie's going to do his usual thing. You never know, we may be joined by other amateurs on calling channel or wherever we're going to go, probably one up from that. So I can't demonstrate it on the air on here because it's not going to obviously do anything. We've got no aerial for 6 meters. So on this one it's channel 75 for calling channel, and the radio is spot on. So thank you for watching the AKD 6 meter FM transceiver, which was mid-90s.